Hello everyone, I am Bhargavi, working as Assistant Professor from the Department of Information Technology, B.V. Raju Institute of Technology, Narsapur. Today, I would like to discuss about the topic of SciPy and Pandas library in Python programming language. So, let's see about what is SciPy. So, the SciPy, SciPy, is pronounced as SciPy. It's an open source library in Python programming languages which is used for mathematics and science and engineering problems. So it includes various modules. So this SciPy includes various problems for statistics, optimization, linear algebra, Fourier transform, image processing and signal processing. So we can use this SciPy library for these applications. So there are various submodules are available to include in these applications. So generally the SciPy is built on a Python NumPy extension. So SciPy is containing some subpackages that helps to solve the most common issues related to the scientific computing. It is very easy to understand and has a fast computational power. So it can operate on arrays which is included in a NumPy library. So we can operate on arrays also using this SciPy, can operate on NumPys. So what are the subpackages in SciPy? These are all the subpackages are available in a SciPy. See, for the file input operations, we can go with the SciPy.io. So, when we include this SciPy.io, we can perform input and output operations. When we want to do some special function, which is like a cube root, exponential, all these are available in special. So, cube root, exponential, permutations and combinations, all these are available in the special functions. We can use these methods using importing SciPy.special package. So when we include this linear algebra for if we want to perform any linear algebraic operation, then we can include the SciPy.linalg, linear algebra. Interpolation. For interpolation also we have a subpackage of SciPy interpolate. For optimization and for the fitness checking, we can go with the SciPy optimize. SciPy stands for the statistics and for the random number generation. So numerical integration, we have SciPy integrate, and fast Fourier transform, we have SciPy FFT pack. For signal processing, we can use SciPy.signal, and for the image processing, we can use the SciPy.nd image package. So this is a submodule. So when we want to use a submodule of that, we have to take the main library with the dot extension to get access of all the functions, methods, attributes inside in our program, inside in our project. We have to do the dot extension of the main library. So how to go with the installation? So we already know that ideally it does not have all these packages, Python ideally. We need to explicitly install with the help of a pip. Pip stands for the preferred installer program. With the help of a pip, we can install any packages and libraries into our PC. So when we go with the IDEs of Anaconda, Jupyter, so all these are by default available. All these are by default available in this IDE. So no need to go with the explicit installation. But if we want anything for explicitly, we need to go with the explicit installation. Ideally, we need to install all these packages manually. So with the help of a pip statement. So how to install this SciPy? So like we installed in the NumPy, pip install SciPy. Pip install SciPy. Just go with the command prompt cmd in our PC. So go with the command prompt cmd and type this pip install SciPy. So automatically it will download all the packages related to the SciPy and it will get installed in our PC. So here is the example for SciPy subfunction submodule is SciPy.special. So among these subpackages have taken SciPy.special package. So what are methods available in the SciPy.special package? We'll see. So it has a cube root, exponential, log sum exponential, lablet, permutations and combination, gamma, hypergeometric and parabolic cylinder, related error, exponential. So all these are the special functions are available in special function of SciPy library. So that can be imported like this. So from SciPy dot, we have to get the special package of special, and in that I am importing, among all these I am importing CBRT. CBRT is a cubed root of a number. So to find a cubed root, I'll write CB is equals to cubed root of, I'm passing a list of 27 and 64. I just want to find a cubed root of 27 and 64. Here the CB is a variable where the result is going to store. CBRT is a predefined function which is available in a SciPy special package. So that is imported like this. From SciPy.special, import the function CBRT. So now I'll get print of CB. So I'll get a result of 3, 4. So likewise, we can do various exponential, log sum exponential permutations and combinations, or we can import that in our program with the help of a SciPy.special library. So how to use those things? So let's see the exponential function. So exponential function, to calculate the exponential, so here is we have a exponent. So first we need to import that one. So how to import is like from SciPy only, SciPy dot, this is available in a special, and importing that exponent. So after importing exponent, so we have storing that result in a exp exponent of 1, 10. So after that we got print of exp. So here we were passing 1, 10 into the list. So it will calculate 1 to the raise of 10, 10 to the raise of 10, and we'll get a result here like this. So this is the exponential of 10. So whatever the list elements we will give, that will calculate the power raise of 10 with that element. So we'll get a final result. So here by default we are importing a function of exp10. So now the permutations and combinations. So SciPy also gives us a functionality to calculate permutations and combinations. So how to do that? So we have to import combo function for the combinations. So that is available in a SciPy.special. So from SciPy.special import COMB. From SciPy.special import COMB. So after importing this combination function, so we just take one variable and we call that function and we pass the argument inside a combo functions. What are all the arguments? The first argument 5 I am giving. 5 represents the number of elements in the set. So 5 elements I am just mentioning. So 2 is the number of elements in each combination. 5, 2. 5 is the number of elements. This is n. Number of combinations at k time. So k is 2. Number of elements in each combinations, and we have given exact is equals to false, repetition equals to 2. Exact equals to false means use a floating point arithmetic operation. So floating point operations, repetition equals to true in the sense that if there is any repetition element occurs in these combinations, it allows. If we give a false, it eradicates the repetition elements. So if we want any repeated element in our combination choices, if we want to allow that, we have to mention that repetition is equals to true. And finally, I am printing this exact is equals to true. If this is an optional one, these arguments are optional. Repetition is equals to true. Exact equals to true means it doesn't allow the floating point operations. So if it is a false, then it allows the floating point operation. So now I am printing print of COM. After printing COM, we will get a result. So how this result is got? So as I mentioned, n is the number of elements in the set, k is the number of elements we were choosing in that set. Exact is equals to, if it is a true, the results will be computed, the result will be compared exactly, and it will be false means floating point approximation. So we will get a floating point here. If it is a true, it is computed exactly, not about a floating point fractional value. So repetition is equals to true means it allows the repetition value, repetition elements while choosing the combination. If it is false, it doesn't allow that repetition combination. So always repetition should be the true. So here this is a combination, so it has gone when n is equals to 5 and k equals to 2. Finally, we got a result of 10.0. So what is a permutation? So permutations, how to calculate the permutation? So permutation we have to calculate by importing PERM, perm. So that is available in from SciPy.special. From SciPy.special, we have to import the perm. Like we imported a com function, like for permutations, we have to import the perm. So same thing, perm n comma k. So where n is the number of elements in the set, k is the number of elements we are choosing for the permutations. So here PER is equals to PERM perm, and I am passing the values, number of elements, and number of elements we were choosing for that permutation is true. Exact is equals to true I mentioned. So it is not about a floating point approximation, it calculates exactly. So here we got the 20, print of perm. So here the formula of permutation is n factorial by n minus k whole factorial. So here 5 factorial by 5 minus 2 factorial. We got 5 factorial by 3 factorial, and the result will be 20. So finally we got the result from the output is 20. So log sum exponential. Log sum exponential is used to compute the log sum of an exponential. So how it is going to calculate is, so here we have to import that log sum exp from SciPy library only. So how to calculate, how to import those things is using from only. From SciPy dot, these are all available in a special, package of a SciPy library. So we have to give it with the dot import log sum. So here I am using that log sum exp. So how it is going to calculate? So log sum exp of x, how it is going to calculate? So log sum exp of x is equals to log of exp of x of 0 plus exp of x of 1 plus exp of x of 2 plus and so on exp of x of n minus 1 values. Here ex of 0, ex of x minus 1, ex of 2, ex of n minus 1, all these are the number of elements in the array. Number of elements in the array. So n is the total. N is the total number of elements. All x of 0, x1, x2 or x of n minus 1, all these are elements in the array. So we are calculating the log sum exponential for that. So this is how we can use the log sum exponential. So let's see about what is Pandas. A Pandas is an open source library which is available in a Python software. These Pandas library especially work with the data sets. So when we want to analyze the data, manipulate the data, when we want to clean the data, when we can go with the Pandas library. So the name Pandas is referred from both panel data and Python data analytics, who was created by McKinney in 2008. He was introduced this Pandas library. So why we use this Pandas? Generally, Pandas allows us to analyze the big data and make conclusions based on the statistical theories. And as well as the Pandas are having a feature of cleaning the messy data and make it readable and relevant. So that is very important to train to the model. So after that, we can get accurate results when we clean all the messy data. So those kind of features are available in a Pandas library. So to clean the messy data, to remove the missing values, to remove the null values, we can go and import the Pandas and we can do the necessary operations on it. So this relevant data is very important in the data science applications. What Pandas can do? So Pandas can do used to find a minimum value, maximum value and average value, and the correlation between the two or more columns also we can done with the Pandas. So this is a data set. How the data set will be appear in the form of a two-dimensional or three. So in the form of a table and row columns. So these are the features. if there is any, pandas are able to delete rows which are not relevant and contain any wrong values, and if there is any empty, any null value, if it is not 0, if it is a null. So these kind of empty and null values can also be removed with the help of a pandas. This is called a cleaning of data. This process is called as a cleaning of data. So how to install this pandas library? So generally all the packages and libraries were installed with the help of a pip. Pip stands for preferred installer program. So directly we have to go to the command prompt in our PC. After going to command prompt, we have to, here we got a window, here we have to type pip install pandas and press enter. So whatever the necessary downloads need to happen, it will happen and it will install the pandas. To uninstall also we can use the pip only. Pip uninstall pandas. Pip uninstall pandas. So after that, we can, now the pandas is ready to use. After downloading, after installing the packages in our library, after installing the libraries in our PC, so we can ready to do that one. How to do that one is, first we need to import that module, import that package, import that library into our programs. Anything we need to import, then only we can do that operations. So with the help of import statements, we have to import the library. So that is import pandas. Import pandas. Now pandas is imported and we can ready to use the modules, libraries, attributes, whatever available in a pandas library. So first and foremost thing is, pandas is especially work with the data set, how to create a data frame. So we have a by default data frame function is by default available. First we need to import that. Import pandas. After importing pandas, I am taking my own data set. I am taking my own data set of dictionary. It's a car is a key and the list is the values. And this is another key of passings and this is the values. So this is there in my data set. So I am calling data frame with the help of a pandas with the dot extensions, pandas dot. So data frame of my data set. So the result completely I am storing in one variable df. So when I go with the print of df, I will get this as a output. So here BMW, Volvo, Ford will be in one column of a column head as a car is a key is acts as a column head and passings is as a column head and these are the rows. So by default, if we are not providing any index, it will take index values of 0, 1, 2. So this is how we will get. Let me show you in the output. So after installing packages, so when we go with the command prompt, so here we are going with the command prompt cmd in our PCs. So we will get this window. So directly whether the Python is installed or not, to check Python version also we can go with Python space -- version. When we do this, we will get a Python version of 3.11. So what are all the packages have been installed? Generally we have to do these installations like pip install pandas. So when I press enter, so pandas package will be installed. Already it has been installed. So I will show that how to see the list of libraries have been installed in our PCs. So pip space install. By seeing this, here the matplotlib is installed of 3.7 version and pandas has been installed with 2.0. NumPy is installed 1.25 version and SciPy has been installed 1.11 version. So to see the what are all the libraries were installed in our, we can go with the command of pip install. If we want to upgrade our pip, so we can use this command python.exe space -m pip install --upgrade pip. So now all the pandas and SciPy have been installed in our PC. So now we can ready to use. So that I'll have to go with the IDLE. I'll go with the IDLE. So this is my Python ideally. So now I will check the version. Import pandas dot double underscore version double underscore. So 2.0. So likewise we can check anything. Import numpy as alias name np dot double underscore version double underscore np dot double underscore version double underscore. We got this version. So likewise we can get this one. So now we'll see how to create a data frame in Pandas. So I'm creating a new file. I'm opening a new file. So I'm just writing like import pandas. So I'm taking my data set which is having car as a key, cars, and I've given a list of cars. BMW is one, Nexa, another thing is okay, I have taken 3 cars. So now I'll give a seats as another key I am taking, and I am passing a list of values inside that. So it is 5 seaters, it is 7 seater, it is 5 seaters. So like I am passing the 3 values. This is my data set which have been created. So now I will use this data frame. So pandas, P-A-N-D-S, pandas. You can give the alias name also. Pandas dot, I am importing a data frame, capital D, capital F. So data frame, inside the data frame I am passing my data set. After passing my data set, I am storing this result in one variable df. Now print of df. So I am saving. Pandas example.py extension. So now I will run the program. So when we run the program, so we got this cars, whatever the list of cars fits. Here we are not passing any index. By default it will generate an index with 0. So we have 3 rows. So it will take 0, 1, 2. So likewise we can create a data frame with the help of a pandas. So how to check the pandas version? Like I have told, import pandas and use the alias name or pandas name with the dot double underscore version double underscore. You have to start with double underscore starting and ending with the double underscore with the dot extensions. We will get the version. Alias name, instead of calling a complete pandas, we can give alias name. So import pandas as PD. So now onwards, whatever you are calling for the pandas, you have to refer it with PD. This is the alias name, you are referring the same thing. So we can use this keyword. So with the help of this, I have checked the pandas version. Pandas series. What is series? So generally pandas series is a column in a table. Data frame is a table. Data frame is a table. Series is a column. Series is a column. It's like a one-dimensional array holding a data of any type. It holds any type of a data. How to create this series? Here creating a simple pandas series from a list. Here we have taken a list. From that we were. So let me check. So same thing. So here we are creating a pandas series. So importing pandas, here I am giving alias name as PD. So now onwards I refer every method, attributes, whatever from the pandas library with the PD name itself I will call along with the dot operation. So here I am creating a pandas series from list. list. Here I am creating a Pandas series from list. So how to create that is, we have a series function. So how to call that one with the help of a Pandas library only. So first we were taking a list A is equals to 1, 5, 7. I have taken a 3 elements in the list. PD dot series, capital S. I am calling a series. Along that I am passing a value of A variable, which is a list. A is a list which is having 3 elements. So print of, here I am assigning this to some variable, some df. I will take df is equals to df. When I save it, I have a series 157 along with the data type D type. So here this is the index values of 0 and 1. Suppose if I want to access only the first row, with the index I can access. Now I want to access only this element, this row. So with the index I can access. How to access that? So df, within a square bracket, mention the index. If I mention the index, I will get that only first index. So if I don't want these 0 and 1, 2, we can create our own index with the index attribute. We can import, we can give our own index values instead of zeros and 1 was system generated. If we want to give our own names, we can give with the help of an index argument. So how to give that one? So those are called as the labels. We can give our own labels. So like here with the index attribute. So generally we have created a list of import pandas as PD. I have taken a list, right? A is equals to 157. I have taken a list. So I have created a variable df. PD, I am calling the series. I am passing this A. If I pass this, I will get 0, 1, 2. Here 157. To get this access, I will give df of 1 means I will get print of fifth value. So instead of that, I don't want 0 and 1, 2. I can give our own values with the help of an index argument. Index is equals to, I am passing a list of x, y, z. And I close. So now I will get output like this. Instead of 0 and 1, 2, I am passing the values of x, y, z. I will get this one. So now if I want to refer this one, I can give like print of df of, within a square brackets, within a quotes, I have to mention that y value. I will get output as 7. So like this, we can create our own index values with the help of an index argument. This is called as a label. So complete. So let us create a simple Pandas series from a dictionary. So I will create a dictionary and I will get the simple Pandas series here. So let me show that. So I am keeping everything in the comments. So creating simple Pandas series from dictionary. So here we have created a Pandas series from list. So now we create a simple Pandas series from dictionary. So how to create? First we have to take our own dictionary. So generally dictionaries are in the form of a key value pair. First we need to import our libraries. Import pandas as PD. I have imported pandas as PD. So now I will create a dictionary. Dict something or else regarding calories. Calories is equals to, I have created a dictionary. So key is day 1 within a quotes. Keys are the string here. So I have taken some value and day 2 given some value. Day 3 and given some value. So this is the dictionary of 3 elements. So this is a key and this is a value, this is a key, and so I am creating a Pandas series from this dictionary. So I have to give that series. So I take a one variable C is equals to, C is the resultant value need to be stored. This C is a variable. I am calling the series PD dot capital S series. Inside that I am passing these calories. After passing the calories, I'll press enter, print of C. So complete result will be here. So I'm taking the dictionary, calories is a dictionary here. So I'll run this. Here the keys will act like a labels. The dictionary keys will act like a labels. So generally when we are creating with the list, here we have a 0, 1 index. So if we don't want 0, 1 index, we can go with the index augment. So here when we give a dictionaries to create a series, here the keys, whatever the keys for the dictionaries will act like a labels. Here these are the thing. Suppose I just want to get only these 2 rows, day 2 and day 3 I don't want this day 1. So I can give that index augment like, so here I can mention index is equals to, within a quotes, day 1, day 2 I am giving, day 3. I just want last 2 and I close that list. I'm saving and I am running. So I'll get only day 2 and day 3. And I skipped day 1. So with the help of index augment, I got this one. So likewise the series, from dictionaries we can create a series, and from a list also we can create a series, and we can create our own index with the index augment. We can create our own labels for that values instead of zeros and ones also. So what Pandas can do? So already Pandas can do cleaning and generating a data frames, especially these data frames, and cleaning a messy data is very important to train a model. So this is what we have seen this. So what is a data frame? So data frame is a 2-dimensional array which is in the form of a table of rows and columns. A series is nothing but a column. So this data frame is called with the help of a data frame function. So how to use a locate variable? So locate attribute is something like which is used to return one or more specific rows. So to get one or more specific rows, we can go with the LOC attribute, locate attribute. How this locate attribute is going to work? See, if I want to return 0, I can give whatever the variable name is there along with the dot LOC of 0. If I want more than one, as I just want row 0 and row 1, so I'll give that specific location that should be mentioned within the square brackets. So how to get access that one? Let me see. See, instead of this, I'll pass a list like, I pass the list. So I get the series. I am creating a series. So I just want to get a row of 0, row 0. How to get the row 0? Row 0, I am just getting row 0. How to get this? We have to use that variable which is getting stored the result. C is a variable where we got a complete series. C dot LOC attribute. LOC of, give that index. If we give the index, here I am giving print of C dot LOC of 0. I got only 2, the row 1, row 1. So I just want 2 rows, 0 row and first row. I can give like 0, 1. If I give like this, I'll get both the rows. See, 0th row and first row if I give like this. LOC is attribute to return one or more specified rows. That should be mentioned within the square brackets. So what is the name and indices? So If we want to give our own name to the index values, we can go with the index attribute. So that is about the named index. We can give name to your own indexes. So with the help of an index augment, like here we have given index is equals to 3 names, day 1, day 2, day 3. These are the 3 indexes which have been created with the index attribute. Instead of 0, 1, 2, we have created our own named indexes. So how to load a files into a data frame? So if we want our data load into our Pandas library, how to load our data file into a Pandas library? Here we have a predefined method of read underscore CSV. So CSV stands for comma separated. So comma separated values. CSV stands for comma separated values. So I have a file which is having values like 1, 2, 1, 2, 3, 11, 12, 13, 14, 15, 16. I have a values with the comma separated. I have to save it with some data dot CSV extensions. I have to save it with dot CSV extensions. This is one text document. Any text document which is having a values of comma separated values, you can save it with the .csv extensions. Whenever we save it with the .csv extensions, it immediately converted into a Excel format. How to load these .csv files into a program? So how to load them into a Pandas to make a data frame is with the help of a read underscore CSV. First we need to import the Pandas library. Then we have to use that Pandas alias name pd dot read underscore CSV and pass your name file. Pass your name of the file with the dot extension. So here my file name is data.csv that I have passed. That should be in a string format. So print of, here I am storing in df. So print of df. So whatever the values are there, so this and all will be in the form of a data frame. Okay. So now we got this will be in a data frame. So that for that purpose we have to use a data frame. So this is how to load a files into a data frame means first we need to use the method of read underscore CSV. We should have a .csv file. .csv is nothing but a comma separated values. So this is a process of loading a data into a Pandas and to make it in a data frame. When I print a df, I will get in a data frame format of the corresponding data. So generally Pandas are mainly used to remove the duplicated values, wrong values, empty values, missing values, null values. So generally Pandas were used mainly concentrated to create a data frames, mainly work on the data sets to make readable and to relevant to perform a model into increase the accuracy. So generally to increase the accuracy, the data should be in a readable format and should be the relevant data. If we train a model with the wrong values, it will give incorrect results. So the Pandas library is especially worked to clean the messy data, to remove the duplicated values and to make it readable and relevant to the performance operations. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.